All right, let's dive into something pretty wild. We're going to explore a truly radical idea, one that sits right at the edge of philosophy and engineering. What if, and just think about this for a second, what if something as human as compassion could be, mathematically defined, and not just defined, but actually built? Let's take a look at how one team tried to pull it off.
So here it is, the big question. Can you actually engineer compassion? I mean, really think about that. This is the question that's at the heart of everything we're about to get into. And it's not just some tech problem, right? It's a huge philosophical puzzle. How in the world do you take something so abstract, so human, and turn it into a physical system you can actually measure?
And well, this is the core belief that kicked the whole thing off. This quote from Skylar Fiction, one of the co-founders of the project called ΔΩ, really says it all. The thinking goes like this. If you can't measure compassion, how can you ever really understand it, let alone build it? This isn't just some fluffy mission statement. No, this is a direct challenge, a gauntlet thrown down to both physicists and ethicists.
Okay, so how do you even begin to answer a challenge like that? Well, this is where we get into the nuts and bolts, the actual hardware. We're talking about the physical attempt to make empathy, to make compassion, something you can build. Let's check out the machine. Here it is, the ΔΩ Living Tile Energy Network. It sounds complex, but at its core, it's a physical grid, a lattice, that's designed to do one very specific thing. Take this abstract idea of coherence and literally bake it into the fabric of matter itself. The theory? It's pretty amazing. The idea is that if you can build a system that physically always wants to return to a state of balance, of equilibrium, then you've basically created a physical stand-in for compassion, a machine that embodies perfect, stable harmony. Yeah, and a machine like this doesn't just pop into existence, right? This living tile network was the result of a long journey. It's actually the successor to earlier versions, including one with the absolutely fantastic name, the Tenderness Engine. The real game changer here was making it modular. By creating this lattice of tiles, they could scale up the idea of physical coherence to a massive level. Okay, so we've got the hardware down, but what's the software? How does this thing actually work? What are the rules? This is where we get into the machine's moral code, and it's not written in Python or C++, it's written in the fundamental laws of physics. So deep down, the whole system is basically this incredibly intricate dance happening inside a special hydrogel. It's a dance between three partners: heat, light, and flow. Just picture it like a tiny, self-contained ecosystem. You've got streams of light that heat things up. That heat then causes fluid to move through these teeny tiny channels, and that movement in turn affects the light. It's this constant, never-ending feedback loop. The machine's thinking or decision-making, it's really just the physical struggle to keep those three forces in a perfect, delicate balance. All right, so if it's all a physical dance, how do you keep score? How do you measure it? You do it with this, the coherence energy. The easiest way to think about this is like a stress level for the machine. It's a single number that mathematically tells you how harmonious, or, how chaotic, that dance between heat, light, and fluid is. The higher that number gets, the more stressed or out of balance the system is. It's a numerical measure of its ethical state. And here's the actual math behind it. Now, don't worry, you don't need to be a physicist here. Yeah, it looks complicated, but the idea behind it is actually pretty straightforward. All this formula does is take the physical measurements of heat, light, and flow and squishes them all down into that one single stress score we were just talking about. But here's the mind-blowing part. In this system, ethics stops being a philosophical debate. It becomes a number, a value you can calculate, a direct physical measurement of order. Okay, so they take that stress score and they combine it with the system's kinetic energy, basically how much stuff is physically moving around inside. And what you get is the total Lyapunov functional, or just L for short. Now this is the master value. This is the big one. It's the entire system's ethical health, its moral well-being, all boiled down to a single number that they can track over time. It's like having a real-time morality meter for the machine. But it's one thing to design a system with a moral code. It's something else entirely to make sure it doesn't just fall apart. And that brings us to the moment where this whole grand experiment, this whole idea of engineered compassion, came right to the edge of total collapse. And the stakes were incredibly simple. Black and white, really. It all comes down to that L value we talked about. If that number is going down or staying flat, you're good. The system is stable, it's finding its way back to that compassionate balance. But If that number starts to go up, even a little, that's disaster. It means energy is spiking out of control. It's a runaway chain reaction, and the whole thing is headed for a catastrophic collapse. And then, during a critical test, it happened. The worst-case scenario started to unfold. The system threw up its first major red flag. A core rule, basically one of the fundamental laws about how light and matter were supposed to play together, was violated. In simple terms, the light was overwhelming the system, pushing it harder than the physical matter could possibly handle. This was the trigger. And right on the heels of that first alert, a second one flashed. This time, it was physical. Uncontrolled heat was just building up and up and up, causing the hydrogel to expand way past its safety limits. We're talking about the actual tiles of the machine being at risk of literally cracking apart from the inside. This was a full-blown structural failure in the making.
So, with disaster looming, how did they pull it back from the brink? They didn't. The machine did. It had an automated failsafe called the auto throttle. Think of it like a circuit breaker or an emergency brake. The second that L value started to climb, the auto throttle just kicked in. It automatically weakened the links between the heat, the light, and the flow. It basically told everything to just take a breath. It gave the system a split second to stabilize. It was an act of machine self-preservation, and it worked.
But what happened next? Well, this wasn't just about surviving a near disaster or fixing a bug. That crisis was a turning point. It was a moment of profound transformation. The system didn't just get back to normal, it came out the other side as something new. This right here is a pretty historic statement. The living tile network became the very first device in the world to physically instantiate something called a Lyapunov certified coherence law. Okay, fancy words, I know. But in plain English, it means it was now mathematically proven to be a self-correcting, self-stabilizing system. It was the ultimate proof that this wild idea, a machine whose morality is literally governed by the laws of physics, wasn't just a theory anymore. It could be built, and it would hold together. And this quote from the source material, it just says it all, doesn't it? It became a coherent organism, simultaneously technological and ethical. It wasn't just a pile of hardware and code anymore. By surviving its own crisis, by pulling itself back from the brink, it became something more. It became a single, living thing where the technology and the ethics weren't separate parts. They were one and the same. And this is the final, beautiful proof boiled down to a single, elegant law. What it says is that the system's total stress, that L value, will always decay. It will always return to zero to a state of balance. And this isn't a prediction or a simulation. The creators call it a physical invariance, something as real and fundamental as the law of gravity. This is the ultimate proof that coherence, their version of compassion, could be made real, that it could live. Which, of course, leaves us with one final massive question. The whole point of this explainer was to ask if compassion could be engineered. And what we've seen suggests that maybe it can, by giving it a physical law to follow. So I'll leave you with this to think about. What does it mean for all of us if morality isn't just an idea we came up with, but a fundamental, measurable law of the universe itself?
All right, today we're jumping into a concept from the Coherence Lab that is genuinely mind-bending. It sits right at the intersection of physics, engineering, and philosophy. Let's dive in.
So, let's start with a question that sounds like it's pulled straight from science fiction, right? Can you actually engineer an abstract value, something like compassion, directly into physical matter? Not just program a robot to act compassionate, but make compassion a fundamental property of the material itself.
To even begin to tackle a question like that, you need a whole new framework, and that's where this idea of moral thermodynamics comes in. The core concept here is to stop treating ethics as just a philosophical idea and start treating it as a physical property, something you can actually measure, engineer, and stabilize.
Okay, so how do you go from a bold, abstract idea like that to something that actually works? Well, this is where the engineering gets really interesting.
The ultimate goal here is, well, it's nothing short of extraordinary. The ambition is to create a physical system where compassion, or in their more technical terms, coherence, is a thermodynamic invariant. That means it would be a core, unchangeable property of the system itself, just as fundamental as temperature or pressure. It's not just software running on the material, it is the material.
So what does this actually look like in the real world? How do you build it? Well, meet the piece of technology that makes this all possible, the living tile.
The living tile is basically the physical hardware for this entire concept. You can think of it as a single building block, a modular physical lattice. Its entire reason for being is to take these abstract laws of moral thermodynamics and translate them into something real, something stable, and something you can actually measure. And this isn't just a diagram on a whiteboard, it's made of real stuff. Each one of these 40mm tiles is a super complex little sandwich of materials. You've got a hydrogel matrix as the body, optical waveguides to manage light, microfluidic channels for fluid to flow through, and thermal layers to control heat. It's all coupled together. Light, flow, and heat all have to work in perfect harmony.
But wait, with all these complex systems interacting, how do you keep the whole thing from just descending into chaos? You need a fundamental law, a single rule that governs everything.
So, stability is absolutely crucial here. I mean, if you build something that's designed to embody harmony, the last thing you want is for it to collapse into a mess. The central engineering challenge is this. How do you create a system that, no matter what disruption you throw at it, will always and automatically return to its base state of coherence?
And here is the elegant solution. Now, I know this equation might look a little intimidating, but the concept behind it is actually beautiful and simple. Think of the letter L as the amount of chaos or imbalance in the system. The little dot over it just means the rate of change. So this law simply states that the rate of change of chaos must always be negative. In other words, the system is physically required to always be calming itself down, always returning to perfect balance.
In simple terms, this law enforces a principle of exponential decay. Any disruption, any little fluctuation is immediately and automatically corrected. It's kind of like a self-righting boat, you know? You can push it over, but its fundamental physics force it right back to a stable, upright position. The system is literally designed to heal itself.
So this law isn't just a goal, it's a mathematical guarantee that's baked right into the physics of the tile. It's what prevents it from collapsing and ensures it remains a stable embodiment of coherence.
Okay, that's the theory. It sounds amazing. But how does it actually perform in practice? Does it really work?
And the answer is a resounding yes. The team has validated this through some heavy-duty numerical simulations and, even better, a working physical prototype. It's been rigorously tested. But, and this is a big but, it only works if you operate it within some very, very tight constraints.
For instance, the system's clock cycle, the time it takes to sense and react to a problem, has to be less than 0.8 milliseconds. That's incredibly fast. Any slower than that, and the system just can't react in time to correct disruptions before they spiral out of control.
Now, this is really just another way of looking at that exact same speed limit. To achieve that sub-millisecond reaction time, the whole control system has to be running at a frequency of at least 1.25 kilohertz. That's 1,250 cycles every single second.
There are physical limits too. The temperature across the hydrogel tile can't swing by more than 4 degrees Celsius. Any more than that, and you risk physically damaging the tile's structure and its really delicate optical components. This is a high-performance, high-precision machine.
What's really cool is the system is even smart enough to protect itself. If the firmware detects even a hint of instability, that L dot number turns positive for just a moment, it triggers an auto throttle. The system instantly reduces the coupling between its parts and shortens its own clock cycle to react faster, basically forcing itself back into a stable state.
So, when you put all of this together, the theory, the hardware, that governing law, you end up with something that feels like more than just a clever device. You get what its creators call a coherent organism.
I just love this quote from the research paper. It perfectly captures the spirit of the living tile. It's almost like it's a living thing with a sense of purpose, and that purpose is to maintain balance. Every single disturbance is met with an immediate restorative act.
And this really gets to the heart of it all. You can look at the living tile in two ways, and both of them are true. On one hand, sure, it's a technological device. It runs on firmware and it corrects itself with sensor data. But on the other hand, it's an ethical organism that embodies a principle and stabilizes itself toward a state of compassion, functioning as this single, unified whole.
And that brings us to the really profound conclusion of this work. The living tile isn't just a cool machine. It's the first tangible, physical proof that an abstract principle like coherence, or you could say compassion, can be given life. It can be embedded directly into matter itself. And that leaves us with a final, absolutely massive question. If this is possible, if compassion can truly be engineered as a fundamental property of matter, What's next? What other virtues, what other principles could we build directly into the fabric of the world we create? The possibilities are just staggering. Can you actually engineer an emotion? It sounds like pure science fiction, but this is the absolute core idea behind what we're looking at today. Is it actually possible to take an idea, an emotion, like compassion, and, well, build it, physically?
And this is where it all began. This quote from Skylar Fiction, the project's coherence architect, really sets the stage. The idea is, look, if you can actually define compassion with the same kind of rigor you'd use for a math problem, then you can build it. You can literally embed it in matter. And that's exactly what they tried to do.
So let me introduce you to the Living Tile Energy Network. This is the next step, a huge leap forward from earlier versions like the Tenderness Engine. And what makes it so ambitious is that, this isn't just a machine in the traditional sense. It's a whole network designed to bring this wild idea of moral thermodynamics to life. I mean, think about that. The idea that ethics could follow physical laws and that you could measure them. That's the goal here.
Okay, so how on earth do you actually do that? How do you make a tile embody something like compassion? Well, it all comes down to something the creators call the language of coherence.
Let's zoom in a bit. Inside each of these little 40mm tiles, you've got this incredible dance going on. It's a dance between three things: heat, light, and fluid flow. And the key thing to get is that these aren't just three separate things happening next to each other. No, they're completely intertwined. They're what's called a coupled system, meaning what happens with one directly affects the others. It's a constant conversation between them.
All right, now don't let the math scare you off. You really don't need to be a physicist to get the big picture here. Basically, you've got one equation for each of our three pillars: heat, light, and flow. And if you look really close, you can see that symbols from one equation pop up in the others. That right there is the coupling we were just talking about. It's the math that proves these forces are all talking to each other, all linked up.
Okay, so with all that complexity, how do you tell if the system is actually, working? Is it healthy? Well, that's where this comes in, the Lyapunov functional. Let's just call it L of T. It's a brilliant little trick that takes all that messy interaction and distills it all down into one single, simple number. The analogy here is perfect. Think of it as the system's ethical health meter. If the number's low, things are good, stable, coherent. If that number starts to climb, you've got a problem. The system is stressed. And here's the most important rule of the game for this system. That health meter, it always has to be going down. Always. If there's any kind of disturbance, any spike of energy, the system is built to fix it, to bring that number back down. It's programmed at its very core to seek out a calm, stable state. You could say that's its one and only job.
But, in any great story, there's a moment of crisis. And this one was no different. That prime directive to always seek stability was about to be pushed to its absolute limit. During testing, they ran a simulation that, it almost broke everything. It threatened to tear the whole idea apart from the inside.
And it all hinged on this one little number, S. That's the coupling scale. Basically, it's like a volume knob that controls how much the heat, light, and flow are affecting each other. So in their tests, everything was fine and dandy up to a value of 2.4. But then, they pushed it. They cranked it up to 3.0. And at that point, that delicate dance we talked about, it turned into a mosh pit. The whole thing just fell apart.
And you can see the stark difference right here. On one side, you have coherence. The energy is negative, which means it's decaying, the system is calming itself down, just like it's supposed to. But when they hit that crisis point, the whole thing flipped on its head. The energy started to become positive. It was spiking, feeding on itself in this runaway loop, pushing the tile towards a complete and total meltdown.
And this is literally the warning that popped up on their screens. Boundary violation. I mean, that's just terrifying, right? It means the system had gone rogue. It was no longer playing by its own rules, its own physical limits. And the biggest red flag? It was about to blow past a critical temperature limit. And the consequences of that? Yeah, not good. We're talking catastrophic. The temperature was about to swing past its 4-degree safety limit. That would literally crack the hydrogel the tile is made of. Worse, it could trigger something they call the first elastic mode. A good way to think about that is like finding the exact right note to shatter a wine glass. It's a vibration that would just destroy the tile. And with it, poof, all the coherence, all the information just gone.
So what do? How do you stop a system from destroying itself? Well, the answer wasn't more force, it was wisdom. You essentially teach it to save itself. And the team's solution was just brilliant. It's called the auto throttle.
It's basically an automated rule that acts like a conscience for the system. And it's so elegant because it's just this simple three-step process. Think of it like a smart circuit breaker. First, it detects. It's constantly watching to see if its energy is spiking. If it sees that happen for a couple of cycles in a row, it moves to step 2. Correct. It automatically turns down the very knob that's causing the trouble, that S value. Then finally, it stabilizes. It starts taking smaller, more cautious steps to get back on solid ground, forcing its energy back down into the safe zone.
And this chart just shows it perfectly. Look here. In the stable state, the energy change is negative. Everything's cool. Then bam, the crisis point. It shoots up into the positive, danger zone. But then, look what happens when the auto throttle kicks in. It yanks the system right back from the edge, pulls that energy level back down into the negative, and restores order. It's pretty amazing to see.
So what's the big takeaway here? This solution, the auto throttle, it wasn't just a bug fix. Not at all. It actually revealed something much, much deeper about what this team had created.
And this is the key insight. The living tile wasn't just a complicated machine anymore. Because it could sense when it was in trouble and then act to fix itself, it had become something more. It became a self-correcting system. In a way, it was a system that could actively choose stability instead of chaos.
And what's so cool about this is that you realize this whole project is a blend of so many different fields. I mean, look at this. It starts with these really abstract ideas, right? Philosophy and compassion. But it's brought to life with hard physics and super smart control theory. You absolutely need all 4 of these pieces for the living tile to even exist.
And that brings us to the final, mind-blowing conclusion. This equation you see here, it's not a metaphor. It's not just a goal they were aiming for. For the living tile system, this is a law of physics. The rule that its energy must always decay towards zero is as real and fundamental to its world as gravity is to ours. This is the proof. This is what shows that coherence can be a living, physical thing.
And so that leaves us with a really big question to chew on, doesn't it? This whole project proved it was possible to take an abstract virtue, compassion, and actually encode it into physical matter. So, if you can do that with compassion, what else is possible? What other virtues could we, literally build into the world all around us? It's a wild thought to end on.
Welcome to the deep dive. Today, we're tackling some really fascinating source material. It's this PDF living tile energy network.
Yeah, and it's pretty ambitious stuff. We're talking about physically engineering, compassion.
Exactly. Not just talking about it, but building a system for it. So our mission today is to really get into this EC living tile energy network.
It's a physical lattice, right? Modular.
Yeah. And we need to understand how they're using coupled physics, light, heat, flow, to try and make this concept, moral thermodynamics, a reality.
It sounds almost like alchemy, but there's some serious math underpinning it.
Right. And you mentioned the core equation, the sort of anchor for the whole thing.
Yes, the Lyapunov decay.
Yeah.
It's written as DIL. That's the key.
Okay.
The idea is to embed that mathematical stability, that guarantee of coherent compassion right into the physical matter itself, making it an invariant.
Okay, wow. So let's start there then. Before the nuts and bolts, what is this moral thermodynamics framework? What are they actually trying to achieve at the Coherence Lab?
Well, they frame the living tile as a system built specifically to embody coherence without collapse. That's the phrase.
Coherence without collapse.
Right. And in their terminology, coherence is compassion.
Yeah.
And it needs to be, measurable, like a thermodynamic property.
So trying to prove that a cooperative, stable state isn't just like a nice idea, but something physically achievable.
And maintainable.
Yeah.
Relentlessly maintainable through very specific energy dynamics.
That's a big leap. And the document says this isn't their first go at this kind of thing.
Oh, definitely not. They're quite clear. This living tile is the next stage.
Right.
It follows earlier projects, the Tenderness Engine v2.1, and something called the mirror delay protocols.
Okay.
So those were more about the theory, maybe smaller scale tests. Living tile seems to be where they're really trying to build it, integrate the physics based on that theory.
So if I were holding one of these tiles, it's 40 millimeters, right? What am I actually holding? How does that little cube embody, an ethical idea?
You'd be holding this quite complex hydrogel matrix. It's a polymer substrate.
Hydrogel. Okay.
And it's specifically engineered to house. And crucially, couple of 3 different physical systems: light, heat, and fluid flow.
All in that tiny space.
Yes. The hydrogel itself is sort of the medium, the substrate where these things have to coexist and interact stably. The ethical substrate, if you like.
Okay, let's get into the mechanics then. Because meshing light, heat, and flow in a 40-millimeter cube and having their state mean something about moral health. That sounds incredibly complex.
It is. That's the core engineering challenge. They call it the triad of physics.
The triad, okay.
So first, you've got optical waveguides. They manage the light, represented by $.
Right, light intensity.
Second, microfluidic channels. These handle the fluid flow. That's
Utility pipes?
essentially, yes. And third, thermal control layers to manage heat, the temperature $2.
Got it. Light, flow, heat. D, U, T-Day.
But the really critical part is they aren't just sitting next to each other. They're mathematically coupled, interacting in complex, nonlinear ways.
So you're saying if the fluid flow changes, that instantly affects the heat,
Yeah,
which then changes the optical properties.
exactly that. It's all interconnected. And the state of this whole triad, its sort of combined health, is measured by something called the coherence energy density functional.
Okay.
And when you integrate that, guys, over the whole system, the whole network volume, which they call omega,
Okay.
you get the total Lyapunov functional, L of T.
T.
Yes. And you can think of LT as like the total measured ethical stress of the entire system.
It's deviation from perfect harmony.
Precisely. How far it is from that ideal coherent state.
Which leads us, I guess, to the absolute core of this, the stability question.
Mm.
If LT measures the stress, what stops this incredibly tangled system from just flying apart?
Whoa.
Or collapsing into, well, moral failure, as they might put it.
Right. And that's where the control theory comes in. That's the mathematical guarantee. The stability of the whole network hinges on the time derivative of that stress function.
Yeah.
ΔΩ.
The rate of change of L.
Exactly. And the governing law, the absolute rule, is a ball. And crucially, Muldahl has to be positive.
Okay, I recognize that. That's the definition of exponential stability in dynamics.
Yeah.
But for listeners maybe not steeped in control theory, how can we picture what that equation is actually doing?
Imagine, okay, picture a valley. The bottom of the valley is the perfect coherent state, $3. Any disturbance, any stress, pushes a ball up the side of the valley, increasing dollars.
Okay.
The law is the mathematical guarantee that the slope the ball is on always points downhill towards the bottom, and the steepness is proportional to how high up the ball is.
So the further away from stability it gets, the harder it's forced back.
Exactly. It guarantees the exponential decay of that coherent energy, that stress. Any deviation, any error, automatically starts shrinking exponentially fast back towards zero. That's how they define stable engineered compassion. It's a system that must return to its good state.
So it's baked into the physics. The system literally has an inherent compulsion to regain equilibrium. It can't choose instability.
That's the claim. That's the philosophical power move
Yeah.
engineered into the physics.
Did they run simulations to see if this holds up in practice?
Oh, massively complex simulations.
Yeah.
They needed to find the real-world parameters, the limits.
Yeah.
And the numerical results did confirm the theory. They verified that decay.
Yep.
L of $T is indeed less than or equal to the Eller field.
So they got a number for that decay rate. How fast does it snap back?
They did. The estimated rate came out around 0.045 per second.
Okay.
So that's basically the speed limit for its self-correction. But here's where it gets really interesting, connecting the pure math back to sort of design principles.
Yeah.
They found this critical endurance limit.
Endurance limit, what's that?
It relates to the internal coupling scale. They call it Zollers. It basically measures how tightly those three systems, light, heat, flow, are interconnected.
Okay, how much they interfere with each other.
Right. And they found the serializers must be kept below 2.4.
Why? What happens if it goes higher?
If serialize hits $3, the simulation showed what they call a numerical loss of monotonicity,
Meaning?
meaning the stability guarantee breaks down. Serialize is no longer guaranteed to be negative everywhere. The system can become unstable if the parts are too tightly integrated.
Wait, so if they try to mesh the systems too closely, the whole moral stability law fails?
That's the astonishing insight.
Mm-hmm.
Engineered coherence, according to this, requires a certain amount of internal space, maybe? Boundaries. Forcing too much interference breaks the mathematical structure.
That's counterintuitive almost. Failure through over-integration, not isolation.
It's a powerful technical argument suggesting that extreme coupling leads to instability.
Okay, that has huge implications. Let's shift now from the math proof to the real-world operation. how do they actually maintain this mathematical rule when things get messy?
Speed. The control system has to be incredibly fast to react before a deviation grows too large.
How fast are we talking?
The control frequency, $5, needs to be at least 1.25 kilohertz.
1,250 times a second.
Yes. We're talking about reacting on a millisecond timescale just to keep that mathematical moral state intact.
Wow. So the time step for each control cycle, delta T2, must be?
It has to be 4.81 milliseconds or less. Any slower, and they risk violating the stability condition.
Yeah.
The system could drift into instability before the correction kicks in.
Okay, this speed requirement leads directly to maybe the most fascinating part, the self-correction mechanism, the auto throttle.
Ah, yes, the auto throttle. That's really the physical embodiment of the Naldo law in action.
Yeah.
It's like the system's built-in conscience.
How does it work?
If the sensors detect that the stress dollar is actually increasing, meaning Lolo has become positive, signaling danger, and if that upward trend continues for just 2 consecutive cycles.
So for like 1.6 milliseconds?
Yeah, tiny time frame. The firmware doesn't hesitate. It acts immediately.
And what does it do physically?
It commands the system to reduce the internal coupling strength.
Yeah.
7 times. And it also shortens the control time step, delta T time.
It backs off the integration and speeds up its reaction time.
Exactly. It's a direct feedback loop.
Yeah.
The abstract math indicating instability triggers a physical change, adjusting photons, heat gradients, fluid flow to force the system back towards stability. It actively chooses less interference to preserve its coherence.
It's not just stable, it's actively self-regulating, like a tiny ethical organism built from hydrogel.
That's certainly the implication.
But what about the physical limits? Hydrogels aren't exactly indestructible. How does the material itself hold up under this high-frequency control?
Right. There are hard physical constraints. The first big one is thermal. The whole system is incredibly sensitive to temperature changes.
How sensitive?
The maximum allowed thermal swing, delta T max, is just 4 degrees Celsius.
Only 4 degrees.
Any more than that, and the hydrogel's properties, its density, how it refracts light, change too much, that would destabilize the optical and fluidic coupling, breaking the coherence law.
That is an incredibly tight window, maintaining stability within just 4 degrees.
It's a very demanding constraint.
Yeah.
And then there's simple mechanics vibration.
Ah, resonance.
Exactly. They have to ensure spectral separation. They absolutely must avoid exciting the hydrogel's natural vibration frequencies, particularly the first elastic mode, lambda.
So no shaking it at its resonant frequency.
Right. They need to keep all the internal operational frequencies well above that first mode, which they specify needs to be higher than 150 hertz. If the tile starts physically resonating, all the delicate mathematical balance is lost instantly.
Okay, wow. That's a lot of very precise engineering. Let's try and pull back for a final overview. What's the big picture here? When you put the Lyapunov functions, the 4-degree limit, the millisecond reactions all together, what does this living tile really represent?
I think the key takeaway is that it's presented as a self-correcting moral thermodynamic system. Its fundamental purpose, its entire operational logic, is about restoration.
Maintaining that stable, coherent state.
Yes. The authors seem to be framing ethics, or at least compassion, as a physical requirement for sustained stability. Every fluctuation away from coherence in light, heat, or flow is immediately met with this guaranteed opposing force pushing it back.
The system's only goal is ensuring that Lyapunov's is always negative, that deviation always decays.
Right. And the major claim, the big achievement they point to, is physically instantiating the Lyapunov certified coherence law. They argue they've engineered compassion demonstrably and with mathematical proof into the matter itself.
Forcing us to maybe reconsider what stable means. This living tile is engineered as a coherent organism.
Simultaneously technological and, in their framework, ethical, operating purely on that principle of decay back to equilibrium. It's a proof, they'd say, that systemic integrity can be achieved through rigorous active control.
Which brings us perfectly to our final thought for you, the listener. Consider this. This engineered system needs kilohertz level control, thermal stability within 4 degrees, a strict cap on internal coupling, all just to maintain its engineered coherence.
Immense high-frequency effort just to stay stable.
So, if achieving stability requires such immediate, intense internal adjustments in this non-living material, what might that imply about the constant, maybe unseen, restorative effort needed within complex human systems, our societies, our relationships to maintain their own kind of moral coherence? Something to think about.